hands-on practical example of how to host a model in Google Cloud. We'll do everything from start to finish. Python code, Docker, set up Google Cloud for the very first time, deploy the model, test it, kill it. This is the most condensed tutorial, but all the important things are explained. Now let's get to it. Here is your model. Now this could be Pickle, JobDip, ONNX, JSON, or any other serialization format. But the model itself is not enough. You probably had some pre-processing feature engineering applied to your data before you trained this model. Let's say you were doing an employee attrition prediction project, and here is your training data. We can see that some of your employees left the company and some didn't, and these are their characteristics. And this is what you have been doing to this data before you trained the model. So you read the data, and there is your target, X and Y. You've done some categorical encoding for categorical features in here, and some simple feature engineering. For example, you took the age group and broke it down into bins of 25 to 35, and so forth. And also you've done some mean target encoding to this age group because they are categories after you've broken them down, and then you encode them with the mean value of the target variable. And there is this mean target encoder class that I've composed quickly just as an example. And then you train a LightGBM classifier and save all your artifacts that are necessary to be applied to the incoming data. That is the categorical encoders, your mean target encoder, and your model pickle. Let's run this script, execute all the data pre-processing and feature engineering, and create all of our necessary artifacts. So I'm gonna do this line by line. So we read in the data. This is the data frame. Attrition column is categorical. So our target is attrition. We split it into X and Y, map the label into ones and zeros. So this way we have a binary column represented as integers. Now we extract categorical features and create a dictionary where we're going to store the column name and the encoder that was used to transform this column. So we've got 7 categorical columns, and for all of them we're going to apply a label encoder and store the fitted label encoder in this dictionary right here. So here we've got for every column their own categorical encoder. And the data frame now is all numeric. We don't have any string columns in there anymore. Now let's do some petty feature engineering. We'll take the age column. Let's have a look. It's currently as an integer, and we will split it into bins and encode them with these strings. So we'll create a new age group column. And this is what it looks like. So since this is, again, categorical, we need to do some encoding. And this time we're going to use a mean target encoder that I handcrafted. It's nowhere near perfect. It doesn't take into account adding random noise to the data, but this is, again, not the point of this video. So we will import this mean target encoder, initialize it, encode the column, and now you can see that this age group is encoded with mean of the target variable. So the final step is to train the model. We're going to fit this model to the data frame, and and let's just save all the artifacts. And as you can see, they all appear in here. Now we need to make a prediction script that's going to do the same thing to the incoming data. We're not going to write it from scratch. I have it prepared because it basically does the same thing, only with minor differences. So at the top, I import everything that is necessary, and this means you have to have your mean target encoder module alongside your model inference file. And one important thing here, so we have imported this at the top for using in the function below. But for unpickling this mean target encoder serialized object, you have to register your custom mean target encoder module in the sys modules. So this is how you do that. So in order for this script to be able to find the files that it has to load down here, it has to know the path to those files. And here are the two options. For running this script locally, this means that the files have to be in the artifacts directory, and here I've got them. And for running in Docker, where artifacts are going to be inside the app directory. You'll see this later. So next, we're loading the artifacts. We're using our preprocess test function that accepts a pandas data frame, these encoders, applies data preprocessing, feature engineering, and returns the preprocessed data set. And the final function to do everything, it gets the input data frame, it does the processing, it makes a prediction, and returns a prediction. That's it. Now, this is how you should structure your files. Let's say you're going to call this service ML service, And let's go top to bottom. Artifacts folder is going to store your pickled files like model encoders or any other serialized objects. The app directory is going to contain your preprocessing code, that model inference script that we created, the mean target encoder class, and the actual API. Well, the requirements are obvious, and there's going to be a Docker file. Now let's create this folder structure and populate it with all the files that we have created. So here we have it. Let's open it up. So this is our model inference script that we just went over. There is the mean target encoder class and the API. It's very simple. It's going to be using FastAPI and Pydantic. This is your input data model with your features. That is a dictionary of a string and any other value, like a number or any other string value. So we initialize FastAPI and create a predict endpoint. So the data that is going to be coming to this endpoint is going to be processed by this function, and it will return a prediction. Don't worry if some of this is confusing, you'll see exactly what's happening in just a moment. Requirements is very important. You have to be using the exact same versions of the libraries that you were using when you were training this model, because if some libraries updates, function calls may change and your model may break. We're not going to discuss the Docker file just yet, because we're going to run this locally using FastAPI and test it on our machine, and then containerize it and test it again, so you would see exactly what's happening at each step of the process. So to install requirements, we're going to need terminal, and if you're running VS Code, the shortcut is Command J. And before we do that, we have to make sure that we're in the correct Python environment. Now I have many, and I use pyenv to manage my environments, and if you're interested how to set it up, and along with that a cool Quake style terminal like that, check out my video, which I will link below. So pyenv global, and the name of my environment is GCP deploy video, and then pip install requirements. I already have them installed, but for you it's going to take some time. Let's clear the console. Next thing we're going to run is this command. Unicorn is going to run the app function from the app directory, and from that app function is going to run the main function, hosted on 4 zeros and expose port 8080. And looks like we've got an error here. So no module found error, model inference. Okay, I see what the problem is. So we need to make this a relative import and save this, and let's have a look at the rest of our code. Okay, and we are also importing this MTE encoder, and this also has to be a relative path. Save this and try running this again. Our service is up and running right here, so you can just copy. Let's open Chrome and paste this in the address bar. And nothing happens. We didn't create any endpoint to show something on this page. We only have a predict endpoint. But since we're using FastAPI, it has a built-in endpoint docs. Just add docs at the end. That will help you test your application in the graphical interface. So as you can see, it has this predict endpoint, and it expects features in this format. And you can try this out, where you can input your features and it will show you the prediction. Put these features in here, execute. Okay, everything worked fine. The prediction is 1. All right, so our API is working fine. Let's, by the way, check what it had predicted. So it predicted 1. And let's look in our training data. We have encoded the target variable that 1 is a yes. And we've used the first row of our data where attrition was yes. So it predicted correctly. We can also test it using a curl command from terminal or a Python script using a request library, but we're not going to do that. We can see that it's working fine, and we still have a long way to go. Now to the Docker file. The first thing to do is to make sure that you have a Docker engine installed on your machine. Now I have mine. If you don't have it installed, you can just Google install Docker engine, and you will be redirected to the page where you can just find one for the operating system. It's very easy, just install it and that's it. After you install it, just open this application and minimize it. So this is basically a list of commands when the Docker image is being built. So the first one is the Python version we're going to use. Now we could have used 3.12 Slim, which is much lighter, but then it would have had LightGBM dependencies problems, so we better use this. It creates a working directory app inside your container, copies the requirements, installs requirements, copies the app directory, artifacts directory, with all your artifacts, exposes this port, and then executes a unicorn command. So again, open terminal, docker build -t app local space and full stop. As you can see, it has executed all these commands, all these steps. Now, I've done this before, so this ran quicker. In your case, it's going to download the Python version and install requirements, so it's going to take longer. So the next step is to run this image. Docker run at port 8080 app local. And again, we can see the same address where Unicorn is running this service. So let's go back to Chrome, refresh. Let's get our sample data, try it out, paste it in here, and make sure that everything works as expected. Okay, yeah, prediction 1. All right, so containerization complete. Now we have to set up Google Cloud. And let's do this from scratch. Go to Google Cloud Console. Of course, you're gonna have to have an active Google account, just a Gmail account. So once you're here, go to my console. And the first thing we need to do is add a billing account, because we're going to be using cloud services. They cost money, and this means you're going to have to have a billing account. Now, don't worry. What we're doing here is not going to incur any costs, and you're going to have to, hit some heavy loads on your application just in order to fill anything. In here, select billing, and we don't have any accounts in here, so we need to create an account. GCP deployment demo. Just add a payment method, which is going to be your credit card. I already have mine. And submit and enable billing. That's it. You have your billing account configured. You have 0 costs, and when you will incur any costs, you'll see the breakdown in here, and there are different reports you can have a look and the cost breakdown. But don't worry, for this demo and even for using this model for quite some time, it's going to be 0. And once we're done learning, we're going to shut down all the resources and delete the billing account, and I'm going to show you how this is done. However, the majority of our interaction with the Google Cloud for deploying the model and testing it and so forth is going to be done through our command line. So this means we need a Google Cloud SDK. Let's have a look. Google Cloud SDK. And you want this one, install the Google Cloud CLI. It's really simple. Again, there are versions for any operating system you might be using, and just download the one you need. So I have a Mac and I have a ARM processor, so I need this one. And these are just simple steps in here. So after you have downloaded this, you actually, let's do this together. I already had it installed, but just to show you how this works. Place it into your home directory. So I'm going to take this file, go into my home directory, paste it in here. I already have it in here, so I'm not going to do this. So let's say I have just pasted it. Next step is you go into home directory and unpack this archive. So just copy this command and execute it in here. Again, I'm not going to execute it because it's going to create a duplicate. And after it is unzipped, you run this command, and it's going to install the command line interface for interacting with Google Cloud onto your machine. And one more thing, after you have installed it, it's going to add a new path into your ZSHRC file. That's your load-up script. So you either have to restart your terminal, or you can just source this file from the current terminal session, and it will do everything for you. Now we have to create a new project on the Google Cloud. Let's go back into the console, just right up in here into the main page. Create or select a project. We don't have any projects. I've deleted everything for this demo, so we create a new project. Let's give it a name, ML deployment demo. Location, don't change anything here. Create. And the one thing we need here is to copy this project ID, and we're going to use it quite frequently for our interaction with the Google Cloud, so we could refer to this project. So just copy this and keep it handy somewhere. I'll just put it in this quick note. Now we have to link our command line interface to that project. So since we've installed the SDK, let's clear the terminal. And in order to link this project to your command line interface so we could interact with this is the command gcloud config set project and the ID of your project. And you have to configure the region as well. So US Central 1. So this means that all the next CLI commands will use the right project and the right region. Now we need to enable all the necessary APIs for our service. So this is the command, gcloud services enable, and the first one is run. The next one is artifact registry, where we're going to store our image. Cloud build is where we're going to build the image, and IAM is where we are going to assign roles or the access to our API. Operation finished successfully. Now the next step is to create a repository for our artifacts, so where we're going to push that Docker image, and we are going to give it a name, ML repo. You could give it any other name. So the format is Docker because we're going to push a Docker image in there, and the location is that region that we have configured before. So run this command. We've created a repository for our containers. Now we need to push our container to that repository. And this has to be done from the root of the directory where our Docker file is. So this is it. This is where we created our API. Let's stop running this container and clear the console. So we are in the ML service root directory where we have our Docker file. So the command is this one, gcloud build submit, and what we have to change here is our project ID. It's going to go to the ML repo that we just created, and it's going to be called ML service. This will take a few moments because not only it pushes your image to the registry, it also builds it in there. And as you can see, it executes commands from the Docker file, where the first command is to download the Python version, which is quite heavy, and then execute all the other commands. Don't mind this error here. This is just saying that my pip is outdated, but this doesn't affect anything. Okay, everything is great. Status success. Now let's check the Google Cloud Console just to make sure that everything is all right. So, okay, this is the build history of this container, and you can check all the logs. So basically it copies everything that you have seen in your terminal as you were pushing this image. You can also check the artifact registry. Here we have our ML repo, and inside it we have our ML service. And in here under the service accounts, we can see that we have our new build added. The services that we have enabled are cloud build, so this is what you're going to see in this report, and artifacts registry. And later when we enable cloud run, this is going to be another paid service which you will potentially see in those reports. It can take up to 24 hours and sometimes even 44 hours after your first successful build. So what have we done so far? We've trained and saved our model locally. We've built a FastAPI inference service. We've containerized everything, and we've pushed it into the Google Cloud. The next step is deploy, what actually hosts your model in the cloud and provides the API access to it. And this is the command, gcloud run deploy ML service. The image that is associated with your project ID, which is in the ML repo, and it is called ML service. This is the region, and allow authenticated. This means that anybody with a link can access this. When we run this command, cloud run will create a serverless container from the image, and it will automatically allocate HTTPS endpoint, and you'll be able to inference that model right away. Now these are quite a few commands we've run so far, and I can see how easily one can make a mistake trying to reproduce this. So I'm going to link below a markdown file where all of those commands are going to be listed step by step. Alright, so this is live, and this is our API endpoint. And this link right here can be used by anyone to query the model. Now let's copy it and try to query this service. We can use curl for starters, and it actually remembered the last time I used this command to make a prediction. So we just change the URL. Let's grab this new one right here. And don't forget the predict endpoint and content type application JSON. And here are the features, the same features we've been using to test this model locally. Run this, prediction 1. And let me explain what just happened. Even though I've been using my local machine to query the model, but I sent a request to the public API URL, which is located in the cloud. We can also do this in Python. We'll open Python in here. This is the code. We're using the request library. Here is this service URL, or the URL where we have deployed our service. The payload is the features, just the same way as we have passed them before when we tested it locally. And the function is just to send a request to this URL with the payload and get a response. Let's have a look. Prediction 1. Let's do one more important thing that is required for any production deployment. So our model is running with the allow unauthenticated flag. If you remember when we run the gcloud run deploy ML service command, it was the last one in there. This means that anybody with this URL can hit your predict endpoint. Now let's make it accessible to authorized users only. And there are two options. We can manage the current deploy and remove the old user's permission from that. And option B is just to delete the service completely and redeploy it fresh without the allow unauthenticated flag. We're gonna go with option B just because it's faster. Before we do that, let's open Cloud Run, just to make sure that we will have deleted it. So this is our current active running ML service. We're gonna open terminal, and the command is gcloud run services delete ML service. This is ML service and we're deleting it. Run this command, confirm, and it's done, deleted service. Refresh and now it's gone. Now this doesn't delete your container image from the artifact registry, it just removes the running service. Now let's use the same command that we used before to deploy this service, only without the last flag, the allow unauthenticated flag. I'm gonna again need my project ID, paste it in here, and here we go. This time it's gonna ask you allow unauthenticated invocations to the ML service. We're gonna say no. Okay, it's done. Let's check our Cloud Run services again, refresh, and we can see that it is in here. Now let's test it. Let's see if it's going to allow me to make a prediction as an unauthenticated user. I'm going to use the curl command and forbidden. Okay, now we want to provide somebody access to this model. You can provide an access to a specific Google account, or for programmatic use, you can create a service account where different software can query this model. Let's first give an access to myself, to my Google account. So this is the command, gcloud run services add IAM policy, and here is the member. This here is my Google account, just my email. And it's given the access to the ML service that we have just deployed. So access granted. And let's imagine I give an access to somebody that's not myself, that's sitting somewhere in another location. In order to query this model, they have to have a Google Cloud SDK installed and they have to be authenticated. So how does authentication happen? In their terminal, they run gcloud auth command. When you run this, it's going to automatically open your browser. You will select your Google account, the same one for which the access was provided. So here is the account that I provided access to. Then it's going to prompt you to allow. And after that, you are authenticated. And now you can use the same curl command that we've been using before, only with a slight change. And as you can see up in here, if we go to the top of this command that I just pasted in, we add an additional line here, Briar, and then execute gcloud auth print identity token. So what this command is going to do is going to get your identity token and include and paste it inside this command. So let's run this and prediction 1. And just out of curiosity, we can run this command down below to see what our identity token looks like. So this string is going to be pasted into here with your query, and it will provide you access to this model. And this is how authentication for an individual Google account works. Okay, so now if we want to allow other users, not just the individual Google account, to access this model, the first thing we want to do is create a service account. Here is the command for that, gcloud IAM service accounts create. ML invoker is the rights that it provides to this service account is to invoke the ML service. The display name is ML service invoker, it can be anything. And the project it is tied to is this our project ID that we have created before. Let's run this. Okay, service account created. We can check whether this exists. So this is the command to list all the service accounts. And let's have a look. Yeah, we've got one right here, ML service invoker that we have just created. For the users, authentication is going to be provided through a key that is a JSON file that I have to generate for this service account. And this is the command right here. So create key, ML invoker key JSON. And actually let's change directory. So I'm going to cancel this. And we go into the desktop so that the key will be saved here. Now paste the command. Here we've got our key that we have to share with the user securely, never by email, so just find a way to provide it to them. So let's say I'm the user to whom the key was provided, and here I have it on my desktop, and I just open terminal, make sure that I'm on desktop, and I run this command, gcloud auth activate service account, and here is the path to my key ML invoker key JSON. Run this command and I'm authenticated, and what this is going to do is that it would make my gcloud session impersonate the service account. And now I can query the model, and there is a certain change to my requests. Let's say it's being done through curl, and here the first thing I'm going to do is to get the token from the gcloud auth print identity token. You remember we've done this before with the private key for private Google account. And then this token is going to be added into here. Basically, it's the same function, only with an additional variable. Okay, it took slightly longer, but we still got our prediction and we can see everything works. So this is how you impose authentication for your machine learning model running in the cloud for an individual with their Google account, or to a certain entity, or even a certain domain. Now, one more very important thing to cover is how to cancel all the running services and even potentially close your billing account. There are quite a few services we've enabled while doing this. So the first one being Cloud Run is where our model lives. The next one is Artifacts Registry, the place where the container image is stored. Cloud Build, that is used for building images. Service accounts like this ML invoker we just created. The project that contains everything that I just explained, and the billing account that pays for project resources. You can delete every single resource one by one, or if your project exists only for this one model, then deleting the whole project is the simplest and the cleanest way. This is actually very simple, but before we do that, let's go into the Google Cloud overview and the dashboard. We will see our project in here, and we would like to see that it has been deleted after we execute this command. gcloud projects delete, and your project ID. Do you want to continue? Yes, we do. API Cloud Resource Manager not enabled on this project. Would you like to enable and retry? This will take a few minutes. Yes, let's do that. Permission denied. Yes, that is because we have authenticated as a service account. Now we have to authenticate back as my Google account, the one that was used to create this project. gcloud auth login. Again, it's going to open my browser. I can select my Google account, the one I was used to manage this project. I'm going to allow, and then let's try again. gcloud projects delete. Do you want to continue? Yes, we do. Okay, we have a confirmation that it was deleted. Now let's go back into our dashboard, refresh, and we can see the message here, project scheduled for deletion. Okay, go to pending deletions page, and it should appear here in a second. We can also check gcloud projects list, and it's going to show us that we don't have any project, 0 items, just what we wanted. Now delete the billing account. So here in the console, you go into the billing account management right here. If you go back a little, you will see that you have only one billing account, GCP deployment demo. Let's go inside of this account, and up in here you have manage billing account and close billing account. It's going to ask you to write close, and here we go. Now our billing account is closed, and we're not going to invoke any costs for any resources on Google anymore. Now you've seen how to deploy the model in Google Cloud and make it securely available for inference. In production, teams also ensure scalability. However, Cloud Run automatically adjusts capacity based on usage, but you can also improve it by making a lighter model or maybe a more optimized processing code. CI/CD to automate testing, building, deploying model updates directly from any kind of version control system like GitHub. monitoring for metrics such as latency, error rate, or any kind of a prediction drift. Versioning using MLflow or artifacts registry so you can easily roll back or compare the performance over time. Security best practices, which we have covered by enabling different kinds of authentication. Finally, maintain clear documentation and governance, that is, describe how your model was built, how it is deployed, what are the expected inputs and outputs. As long as the model is properly deployed and secure, all other things that I mentioned are optional. Now you can host your models like a pro and brag about your advanced machine learning engineering skills and Google Cloud experience, which is a strong selling point, by the way. I'll see you on the next one.